Hi everyone, thanks for clicking and welcome back to my channel. Today we'll be talking about the difference between pressure altitude and density altitude and why do we need them. Let's look at the pressure altitude first. By definition, pressure altitude is the indicated altitude when the altimeter is set to 1013 hectopascals or 2992 inches of mercury. It is the altitude above this datum plane. As we all know, the atmospheric pressure is not constant all the time. It changes depending on the pressure system in the region. So the altimeter setting we get from the ADAS, tower, or METAR is called QNH, such as 999 hectopascals, 1005, 1019, etc. This figure allows the altimeter in the airplane to calculate the indicated altitude above mean sea level. Now, let's see how is pressure altitude important to us. Firstly, we need pressure altitude to be able to calculate density altitude, and we need density altitude to figure out our airplane performance. Because all the performance data published in the POH or the AFM, Airplane Flight Manual, are based on density altitude. We will look at density altitude and how to calculate it shortly. Another reason why we need pressure altitude is that when flying at high altitudes, especially when transitioning from altitudes to flight levels, we switch our altimeter setting, or QNH, to read standard QNH, which is 1013 hectopascals or 2992 inches of mercury, meaning at the transition altitude, which is the altitude at which we switch from local QNH to the standard QNH, we join flight levels. The transition altitude changes from regions to region, from FIR to FIR, depending on the authority of that state. So all flight levels are actually pressure altitudes. Okay, now how do we calculate this pressure altitude? Well, there are two ways. First method, the easiest, simply setting your altimeter to 1013 hectopascals or 2992 inches of mercury in your aircraft. And the altitude that is displayed is your pressure altitude. The second method, you say you're not on your airplane, for example, you need two things to be able to calculate your pressure altitude. First, you need the current QNH and the airfield elevation. And here is the formula. The pressure altitude equals 1013 minus the QNH, current QNH. We multiply the difference by 27 and we add the airport elevation. Let's do an example together. Okay, say for example we have a QNH at a certain airport, 1002 hectopascals, and the airport elevation is 50 feet. What is the pressure altitude? Okay, let's substitute in the formula and we get 1013, it is constant. Why 1013? Because it's the standard QNH from which the altimeter reads the pressure altitude. Okay, so 1013 is constant in the formula, minus 1002, which is the QNH. The difference, we multiply it by 27 and then we add the airport elevation 50 feet. We get 11 times 27 plus 50 and we get the pressure altitude of 297 feet. Okay, let's do one more example. Say for example we have a QNH of 1030 hectopascals and an airfield elevation of 10 feet only. So merely it's about sea level. So the pressure altitude 1013 minus 1030 multiplied by 27 plus 10. Okay, we get negative 17 times 27 plus 10, negative 459 plus 10, and the pressure altitude is 449 feet below the datum. Okay, so the pressure altitude is negative 449. Yes, we can get the pressure altitude positive or negative, depending on the datum of 1013. Is it above sea level or below sea level? All right, now let's talk about density altitude. Well, density altitude, by definition, is the pressure altitude corrected for non-standard temperature. What does that mean? Well, basically it means that we have standardized our pressure altitude based on a standard atmospheric pressure of 1013 hectopascal. But how about air temperature? Because not only pressure that affects density, also temperature. So according to ISA, sea level air temperature is 15 degrees, and then it decreases 2 degrees, roughly 1.98 per 1,000 feet, gain in altitude. But this is not always the case in real life. At sea level, it may be 15, it may be colder, or it may be hotter than 15. So we need to standardize the temperature as well to get a standard atmospheric conditions from which we can figure out our airplane performance. So let me simplify this a bit more. In order to be able to figure out exactly our airplane performance on a specified day, we need to standardize that specific day's pressure, which is why we calculate the pressure altitude, as well as standardize the air temperature, and which is why we correct that previously calculated pressure altitude to standard temperature. Then we end up with density altitude. With density altitude, it becomes easy to anticipate or figure out, for that matter, our aircraft performance. And what do I mean by performance? Takeoff and landing distances, takeoff and landing rolls, climb performance, cruise performance, fuel flow, etc. Alright, now let's have a look at how to calculate the density altitude. Here is the formula. Density altitude equals pressure altitude plus 120 times ISA deviation. So as we have just said, density altitude is pressure altitude corrected for non-standard temperature. So let's correct this previously calculated pressure altitude to non-standard temperature. Okay, in the previous example, number 1, we had the pressure altitude of 297 feet. Let's say we have an outside air temperature of 35 feet. What is the density altitude? Okay, let's plug the values we have in the formula, and we get 297 plus 120 times ISA deviation. Now, what is ISA deviation? It is how many degrees the actual temperature has deviated from the ISA value at a specified altitude. Meaning, ISA temperature at sea level is 15 degrees. Okay, the standard. And if the actual air temperature at sea level at that day is 20 degrees, for example, this means that the outside air temperature has deviated by plus 5 degrees, meaning ISA deviation is plus degrees higher than the standard ISA temperature. I hope you got it. So let's calculate ISA deviation now. So ISA deviation is outside air temperature minus ISA. Okay, the outside air temperature is given as 35 degrees, my bad, minus 15 degrees. Why 15 degrees? Because we are at sea level. The airport elevation is about 50 feet. At 50 feet, we can consider it sea level. So we have 35 minus 15, and we get 20. 20 degrees is the ISA deviation. Now we can continue plugging the values, and we get density altitude equals 297 of pressure altitude plus 120. We multiply that by 20, which is ISA deviation, and we get 2,697 feet. So let's round it off to 2,700 feet for simplicity. Now, what does this figure tell us? It simply denotes that the airplane, though it is at sea level, 10 feet of elevation only, it will perform as if it were at 2,700 feet. The airplane will feel like it were at 2,700 feet, meaning a relatively lower performance and degraded performance. Let me just repeat this for simplicity. Even though the aircraft is at sea level in this example, because of a reduced density due to a higher density altitude, the aircraft will feel and perform as if it was already at 2,700 feet, even if it is still technically and physically at sea level. Okay? So the takeaway here is that the higher the density altitude, the lower the degraded the airplane performance is, and vice versa. So I hope you got the difference between pressure altitude and density altitude. Just a summary, quick one. Pressure altitude, we need it to fly flight levels. Once we reach the transition altitude, we switch from local QNH to the standard QNH, which is 1013 hectopascals or 292 inches of mercury in regions where they use inches of mercury. And whatever the altimeter reads, that is pressure altitude. So flight levels are actually pressure altitudes. And number two, we calculate pressure altitude, and then we correct that pressure altitude for non-standard temperature, deviation of temperature from ISA, and we get the density altitude. And the density altitude, from it, we can anticipate our aircraft performance, because the data in the POH and the AFM are all based on density altitude. So I hope you guys found this video helpful. If you have any questions, feel free to leave them in the comment section below. I'll be more than happy to answer you guys. Thanks for watching, and if you found this video helpful, kindly consider subscribing, because that will help the channel. Thank you, and see you.